So I'm putting this one because I messed up on the other one. I don't want to erase it and make the paper look ugly. But we graph it in decibel, 20 log the magnitude. That's what we graph. And just an example here, you can see actually as you go from 1 to 10 to 100 to 1,000, each time the value is increasing by 20 decibel. That's why the rate goes up at the rate 20 decibel per decade. Or if it's going to come down, it's going to be 20 decibel per decade. Unless you have double poles or double roots there. Zeros and poles. We'll talk about that later. So there's the function I'm using. To graph that, it's going to be 20 log the absolute value of that, which is this one. Again, I had this nice and neat, and this is for A less than W, or let me just rewrite that. I don't like the way I wrote that. That means what? W is much bigger than A. Right? Isn't that the same thing? For W much, much bigger than A, it's not worth adding the 1 to it. So your function becomes this, and you end up with this expression. That's just an example. If we said W is much, much bigger than A, or A is much, much less than W. So I'm making alpha or A equals 0.001. So that's why you can drop that. The second one here, again, you can stop these if they're moving too fast when you go home and look at them. If A is less than W, which means W really is much, much less than A. If you go back to this one, W is way smaller than A, this will go to 0. And you end up with 20 log of 1, which is what? 20 log of 1, that happens to be 0. Log of 1 is 0 times 20, that's a 0. And when alpha equals W, this is a 1. This will be 20 log the square root of 2, which is 3. Now let's graph it. And that's the part I made a mistake on that one. Turned out to be ugly looking. Sometimes my brain. And let me put A or alpha somewhere here. So this is W here. And this is the decibel. So this is A. When A is really a small value, W is much, much smaller than A or alpha. That's on this side of it. What was my decibel value equal to? Wasn't it 0? So my graph, do I have a thick marker somewhere here? Yep, here we go. My graph will look like this. Now again, you can try value like what? You can say, well, I'm going to go through them and plug in numbers. W is less than A, we're saying. If W is much, much less than A, so W equals 0.01 A, or 0, or just 0.1. I'll do this. Get back here. Like 0.1 A alpha, or W equals 0.01 alpha, or W equals 0.001 alpha. W is much less than A. My answer is 0. Don't waste your time on it. What happens when W is greater than alpha? Like here we go. 10 alpha, 100 alpha, 1,000 alpha. Go back to this equation. When it's 10 alpha, that would be 20 divided by, or 10 alpha divided by alpha, that's 10. What's 20 log of 1? log of 10. What's 20 log of 10? Log of 10 is 1 times 20, that'll be a 20. This is like 20 decibels here. When it's 100 alpha, this will be 100. What's log of 100? 2. 2 times 20, this will be a 40. Next one. When it's 1,000 there, that would be a log, would be 3 times 20, that's 60. So what you're going to notice, the graph looks like this. It's rising at the rate of what? 20 decibels for every factor of 10. So when I do the Bode plot for that function, I'm going to graph it like this. What's going to happen to it in real life, actually, when alpha equals W, I did the calculation for that. What was the value in alpha equals W? 3 dB. So the graph really is going to be like this. Where's my red marker? 0, and it loops up there, then it levels like this. And that gap here is actually 3 decibels. That's when alpha equals W. How fast is it rising? At the rate of 20 decibels per decade. Now let me go back and visit that function, 1 plus s over alpha. If I write that, my LCD is what? My 1 plus s over alpha. My LCD for these, if I was to add them, would be alpha. Alpha is a number, so I can write that s plus alpha over alpha. This is known as a 0. When you have a fraction, the value that will make the top 0. So usually the value that will make the top 0 is what? It's negative alpha. But notice here I wrote what? Alpha. There's no negative frequency. So we say find your zeros, which is take the top, set it equal to 0, and take the absolute value of that number. That's what called the zeros. Every 0 is going to pull the graph up by 20 decibels. Every pole is going to pull it down by 20 decibels. So if you look at that, S equals the absolute value of negative. So that's why you go, that's a 0. A 0 is going to pull you up, so let me just write that down. Every 0, you see that from the picture. I want to derive that for you. Every 0 is going to pull you up at the rate of 20 decibels per decade. And every pole is going to pull you down at the rate of negative 20 decibels per decade. So once we understand that, I can take any expression now and graph it without having to go through all these calculations. I just want to prove that to you here and go from there. So let me take an expression.
Is it always going to be 20 log?
Yep, correct, because the equation is 20 log. Now if you get 2 of them, which you'll see that like s squared, because you get s times s. You get 2 of them as 0, for example. Each one is going to pull either up or down. It depends if it's on the bottom or on the top. So if you get 2 of them, it'll be 40 decibels. So let's see what's happening. Let me take an expression and show you how quick we get to the answer. Let's say we have an expression. I don't care what the circuit looks like, but you did the math, and your expression happens to be this. Negative 2 times S over 1 plus S over 10, 1 plus S over 20,000. And I want to do the Bode plot. I got 3 values to pay attention to. I call them zeros and poles. That's the top. Zeros for the top. That's S equals to 0. There's nothing plus nothing here. because you can write the SS plus 0. The poles here, I see two of them. I see one of them where? What do you think? Isn't the 10 one of the crucial values? Because if S is less than 10, what will happen to that? This will go to 0. It's not worth adding, becomes that number. So I have 1 at 10, and I got 1 where? At 20,000. So here's my Bode plot. I'm not going to start at 0. I'll start my graph, I don't know, 1 at 2, whatever. Let's say, for example, this is, well, this is the 0. I'll make this the 1 here. This is S equals 1. This is S equals 10. This is S equals what? 20,000. From 0 on, you get a 0, and the 0 pulls you up at the rate 20. I'm not sure where it's coming from, but it's rising at the rate. It's coming from maybe S equal to 0 was down here. But it's coming from down there and pushing you up till we get to this value. At the rate of 20 decibels per decade. Till we hit that 10. The 10 is a pole. Hello.
This is your class runs right now? Oh.
Not really.
No, just help session.
Oh, well, can I interrupt you for a second?
Sure. You're going to be on camera on TV now.
I don't want to go on TV. This is just a computer science advising question.
Yes.
So, first of all, he's still listed.
I gotta say sorry to the guys listening to me in case they watch the
Oh.
video.
Oh.
It's all right, no problem. I can look quickly.
So my question is, this is not offered in the fall.
No.
And can he take these if he's only going to be in pre-calc in the fall?
In pre-calc?
Yeah,
No.
he's not,
No.
okay.
So if you want to wait, I can look at his schedule. Yeah, no problem. So what is the 10 gonna do? It's gonna pull me down what? At the rate of 20. So right here, this continued to go. Just imagine this going up. Doesn't stop. But now we get the 10, and you get a pull. It's going to start to pull down on you by what rate? By 20 again. So I'll do a different color. So what's going to happen to your picture? This is going up 20. This is coming down at 20. So what will happen to my graph, here we go, I'll make it permanent now, is going to look like this. When it hits this point, it's going to level. Because these guys will cancel each other out. The minus 20, the plus 20, they'll cancel each other out. And you will stay like this till what? Till we hit this point. And what's going to happen when you hit that point? What's going to happen after that? Do you have a pole or a zero? The bottom is poles, the tops are zeros. So that's a pole, another 20 decibels per decade, and it will come down at the rate of 20. The only thing you got to do now when you do Bode plot, you have to put a value, one value on the graph. And the reason for that, if I need to go back to my function, if you don't give me a number, I have no idea what that negative 2 in the front. I don't know what that number is. That could be 5, 7, 12, 14, 88, whatever. So you got to pick a value on the graph. It doesn't matter which one. And you give it an answer. Well, you know what? I'm going to use this number, the 10. So you can use the 10 and find what the value for it should be. You can use the 20. You can use any of these values. So if you opted to go with the 10 or like the 10 here, You might say, I want to give you a number here. This will be 20 log the absolute value of negative 2 times what? 10 over 1 plus 10 over 10, 1 plus 10 over 20,000.
Before you say that, zero.
That's 1/10. I mean, that's almost a 0. That's a 1. This is a 2, so you end up with what? 20 log negative 21, the absolute value of that, right? So what was the absolute value of that? Over, what do we have here? 2 in here? And this will be roughly 1. That's a 2, that's a 10, negative 10, take the absolute value, that's a 10, right? What's 20 log of 10 is 1? Times 20, that would be what? 20 decibels. You could have used the 1. You could have used the 5. Any number you want to use. But you have to pick a point on the graph and let me know what is the decibel there. So in case I have to go backward. Notice the nice thing about this, just if I cover it, why we like it. Let me cover it actually. Now you don't see the expression. You go, okay, can you look at the picture now, give me the expression. I go, well, it's going up. Started by going up at 20 decibels. What does that mean? There must be a 0 at the origin, a 0. It leveled here. Why did it level? That means something was pulling down on it at 20 decibel. Oh, that must be S plus 1 over 10. There's a pole here in the bottom. I mean, 1 plus S over 10. I said it backward. It must be another pole where? Because it started to go down here at 20,000. S here, not a 5. And there's some constant in the front. I don't know what the value of the constant. That's what my expression is. Just by looking at the picture, I can get you the expression. And that's where the point comes in. I go, wait a minute. When S is 10, my value was what? 20? So let's see if I can get that expression. 20 equals 20 log absolute value K times 10 over 1 plus 10 over 10 is 1. 1 plus 0, that's 1, roughly. That's a 1 if you divide them. Is that K10? And look at K now. We go, well, that's a 1. I can rewrite that 10 to the power of 1 equals 5K. Because this deals with the absolute value, you don't know if it's plus or minus the number. But the value of K is actually a plus 2.
Would you get a rise?
Huh?
How would you get a rise in the graph?
What do you mean a rise in the graph? To go up there?
Yeah.
If I instead of this being in the bottom, if I put that on the top. If this wasn't here, was on the top, 1 plus S over 20,000, that would go up instead of coming down. Let me try another one. Let me see if I can find a big one, like with a lot of stuff, and go to the end of the chapter.
What if you have like 3 rises?
You can have three, it'll be 20 and 20, and it'll be a 40. I'll give you one. I'll make one up. I was looking in the back of the book, but you're excited about this, so I don't want to discourage you. I like when people are excited. So here we go. You want rises, falls.
So this is, the S means the S
J-
domain, right?
Correct. JW. We just lazy the JW 2 letters, we use S. So let's say it's equal to 7 S plus 1 S plus 50 over S plus 10 S plus 100 100, I meant to write, here we go, that's 100 S plus 1,000 S plus 10,000. Give me, well, usually I don't write them this way. I try to write them what? I can change that number in the front. We like to write that 1 plus S over 1. So that's easy to do that. How do you do that? We divide every one of them by S, right? So if you divide each one by S, I should write them like this here. And this will be 1 plus 50 over S. This will be 1 plus, because you're dividing by 10. I'm dividing by 1, I'm dividing by 50. Well, if you're dividing by 1, it really doesn't change anything. But this one, you're going to divide by 50, what's going to happen? You change the value of the fraction. You agree with that? If you divide every one of these by 50, it's not the same one. 1 plus 50 over S is not the same as, well, actually this one should be S over 50. My S is in 5s. That's S. 1 plus S over 50. I divided each one by 50. Well, if you look at the top of a fraction, and you go, you know what, there's my fraction. I'm feeling like dividing everything by 5 here. You can't just do that, right? What you can do is, you know what I'm going to do? I'm going to multiply this by 5 over 5. That's a 1. So if you divide everyone by 5, so you can distribute that 1 over 5 in front of that, that becomes what? X over 5 and 5 over 5. So what happens? You still get the 5 in the front. So when I divide here by 50, I really pulled out 7 times 50 in the front to make sure the function doesn't change its value. So if it's given to me like this, and I want to turn it to this, that's what I got to do. Now let's look at this. I'm going to divide everything by 10. That'd be 1 plus what? S over 10. That means I got to multiply this by 10. 10 times 1 is 10 plus S. That's this one. I'm going to divide by 100. S and S looks like that. That means I got to multiply by 100 in the front here. I'm going to divide this by 1,000. I got to multiply this by 1,000. And this one, that's by 10,000. And I got to simplify my math. Now, get one number for that. So this expression becomes 7 times 50. Let me get a calculator. I don't need this too fancy one. Seven times 50 is what? 350 divided by this big number. divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, divided by 1 EE to the power of 10, right? Where's EE? EE, where'd you go? Oh, I see it. The power of 10. That's going to be 3.5 times 10 to the power of negative 8, if you clean it. If you're lucky, they give you the expression like this, so you don't have to do all this extra math. One plus S over 10,000. So poles, here we go. Where are my poles? These are the top. Poles, the poles at the bottom, zeros on the top. The top, the 1 and the 50, that's an S, not a 5. At 1 and 50. These make me go up. The poles, where we have them? At 10, 100, 1,000, and 10,000. They make me go down to 20 decibels. Now I'm ready to graph it. And again, I have no idea where they're coming from. So I'll put a 1 here. I'll put a 10 here. I'll put a 50 here. I'll write these numbers. I'll put 100 here. Don't worry about the scale. I'll put 1,000 and a 10,000. Now, that means it was constant somehow. And I don't know what that number is. But it was constant. There was no poles at 0. There was nothing at 0. That means your function was flat. If you got a pole at 0, it was coming down. If you have a 0 at 0, it was going up. So it was flat till we hit the 1. And that's not a 0, that line here, by the way. We'll come up with the value for that one. Then suddenly we hit the 1. When you hit the 1, what do you have? You have a pole that goes, a 0, that's going to pull you up at the rate of what? 20. Till we get to this number. What happens when you hit that number? What do you encounter? At 10, we got a pole. So it's going up, and when it's pulling down, it's going to level, it's going to cancel it. It's going to go like this till it hits 50. What happens at 50?
Goes to 0.
It's actually, there's a 0 here. See the 0 at 50? It's going to go up at 20 decibels. Till we hit the 100. So a little bit farther. Go. And what happens when you hit the 100? You encounter a pole. So it's going up, and this is going to pull down. It's going to level it. Till we get to the 1,000. What happens after the 1,000? You encounter what? Another pole at where? At 1,000? There's the 1,000 here. So what is the pole going to do? Bring you down at 20 decibels now? Till we hit 10,000. And when you hit the 10,000, there comes another pole. So this will be much steeper now at 40. So here we go. Flat, rising at the rate plus 20 decibels per decade. Flat, plus 20 decibels per decade. Negative 20 decibels per decade. And now negative 20 plus negative 20, that would be negative what? 40 decibels per decade. Is that what you were asking, if you have two of them?
Yeah.
So that will pull you down by 40. If I have a third one, we'll be coming down to 60.
So you'll never get a vertical line?
Straight line?
You want-
You have to have infinite of these. So physically, no. Or mathematically. Now, we're going to pick a point, any point on the graph, and assign a value to it. So you might choose to pick any number, like I'm going to use a 5. Whatever you want to use. I'll pick something that's not on it, so people will know when they look at it, okay, he put that point for a reason, for me to know. So I see, the 5 is somewhere here. I'll write the 5 in different color, and I'll go right there and give it a value. And the value should be what? It's going to be 20 log the absolute value. Now let's go back to this function. You can use either one here, because this is the same as this. So I'll use that one, that's easier. When s equals 5, what's 5 plus 1? Isn't it 6? 5 plus 50, 55. 5 plus 10, 15. 5 plus 100, 105. 5 plus 1,000, 1,005. 5 plus 10,000, 10,005. It's going to be a very small number, or negative number.
Why are we doing at 5?
Any value, you can pick any point. I just chose 5. I could have picked 2, 3, 11, 17, 20, any number I want, any value.
Okay.
But you got to pick a point and give the person looking at the graph a reference. How high? Because they might be thinking that's 0. And your guess is good as mine what that value is. I could have picked the 1 to let them know this line is not really 0. So now let's see what that number is. That's a tiny number. That would be 20 log, here we go, ready for this number? 1.4586 times 10 to the negative 7. That's a little bit more than negative, so this is going to be about a 7 here. Actually, no, this will be negative 7, I mean. So let's take the log of that. Negative 7, negative 8. What's the log of that number? 6.83, right? Times the 20. So yeah, you're right. That's negative 136.7. So you know this is not 0. Yeah?
We can see what the math is in the bottom.
Oh. So you know that number is not a 0. So this does not represent 0. It could be any number. I could have picked the 1 here to get exactly what that value there. That might be negative 170, 180. Again, if I give you this picture, I can go back to the expression. I know I have 1 plus 1 over s here. I have a pole at 10 because it leveled 1 over s plus 1 plus s over 10. I got a 0, 50, 1 plus s over 50. I got a pole here, 1 plus s over 100. I got another pole here, that's in the bottom, 1 plus s over 1,000. I got another pole here, 1 plus s over 10,000. And it will be a k in the front, and you work the problem and you get what k is equal to. Okay, What happens if you have a quadratic? That's tomorrow. I'll go to my next class.